So we were talking about permutations, and then we started talking about combinations. In CR, the N stands for how many objects you have to choose from. The R, the second number, which is usually smaller, tells how many out of those N objects you're actually selecting. And the whole thing in CR represents how many ways you can pick R out of N objects when the order in which they're chosen does not matter. All that matters is which ones you choose, not which one's first, which one's second, and so on. So the number of ways to choose R number of objects from among N that you have to choose from, where the order does not matter, is denoted in CR, with the two numbers as subscripts on either side of that big letter C. Other books use other notations, like C and then N and R in parentheses after it, or just a big old set of parentheses with the two numbers N and R, N on top and R on the bottom, no fraction bar, just the two numbers. That's another notation that's sometimes used. But I'll stick with the NCR notation. So how do you actually calculate it? Well, three main possibilities. You could count the number of permutations, one of the ways we talked about to do that, and then divide that number by R factorial. You could use the built-in function or button on your calculator for calculating combinations in CR. Or the formula for NCR, if you just want a formula that you can plug the N and R numbers into, would be N factorial on top divided by N minus R factorial times R factorial on the bottom. You'll notice that looks a lot like the formula I showed you earlier for NPR, but it has an extra R factorial in the denominator. So that would be like if you took NPR and then divided by R factorial. So for example, to calculate 9C3, which would represent how many ways you can pick three things out of 9 where the order doesn't matter. You're just counting how many different sets of 3 there are. So we could take 9P3, which would be 9 times 8 times 7, and divide that by 3 factorial, 3 times 2 times 1. So that would come out to be 504 divided by 6, which is 84. Or you could use that N factorial over N minus R factorial times R factorial formula. So N is 9, N minus R is 9 minus 3, which is 6, and R is 3. So on top we have 9 factorial. On the bottom we have 6 factorial times 3 factorial multiplied together. And then when you divide those, you end up with 84. Now here's the calculator function. Some calculators actually have a button labeled something like NCR that you can use. Some calculators have a PRB button that you would push to get to the little menu that includes NCR. On this calculator, to do 9C3, first I'd put in 9, then push Math, go over and select the PRB menu, and there's NCR, it's the third thing on the list. So if I choose that, and then put in 3 for my second number, so I'm doing 9 NCR3, that does come out to be 84. And remember earlier we did 5C3, because we're picking 3 movies out of 5, and if the order did not matter, there were 10 ways of doing that. So just to check that, 5 NCR 3, the calculator agrees, that's 10. How many different groups of 4 people could be chosen from among 25? So this time we're not talking about specifically picking one of them to be president and one of them to be vice president and one to be secretary and one to be treasurer. We're just picking a group of 4 people. So does order matter? No. All that matters is which 4 people get chosen. So we are doing combinations. That's what makes this a C and not a P. How many do we have to choose from? 25. So it's 25 CR. And how many of those 25 are we actually choosing? Well, 4. So it's 25 C4. Now to actually calculate that, it's going to come out to be 12,650. So we could do 25P4, which was 25 times 24 times 23 times 22, and then divide that by 4 factorial, 4 times 3 times 2 times 1. So we could calculate it that way. Or we could use that formula with all the factorials in it. Or we could use the calculator. 25, math, PRB, NCR, 4. So 25 NCR 4 is 12,650. How many ways could a diner, like a restaurant customer, select 3 side dishes if there are 9 to choose from? Does order matter? No. All that matters is which 3 sides get chosen. So it's C. It's a combinations kind of question and not a P, permutations kind of question. So we're going to be doing NCR. What number are we using for the N? How many do we have to choose from? Well, 9. And what's the R? How many out of those 9 are we actually going to select? 3. So it's 9C3. So do that using your calculator's NCR function, or calculate in P3, which would be 9 times 8 times 7, and divide that by 3 factorial, or use the factorial formula. However you do it, it comes out to 84. 84 ways of picking 3 out of 9 possibilities. How many ways could you select 3 men and 3 women from a group of 18 men and 19 women? Oh, now this is a little more complicated because we're going to be using the fundamental counting rule and the rule about combinations. We're making a sequence of choices. We're picking 3 men out of the 18 men that we have to choose from, and we're picking 3 women out of the 19 women that we have to choose from. So the answer, we need to find the number of ways of selecting the 3 men times the number of ways of selecting the 3 women to come up with the number of ways of selecting 3 men and 3 women. Because any of those groups of 3 men could be put together with any of those possible groups of 3 women. So the number of ways to select the 3 men from among 18, that would be 18C3. The number of ways of selecting the 3 women from among 19, that would be 19C3. Then we got to multiply all of that together. So 18C3 is 816. That's how many possible groups of 3 men there are. And 19C3 is 969. That's how many possible groups of 3 women there are. So the number of ways of selecting 3 men and 3 women would be 816 times 969. Remember, going back to that number of ways of doing A and B is the number of ways of doing A times the number of ways of doing B. And that comes out to be 790,704. So that is the final answer to this question. So in this section, we've been focusing on counting questions. How many ways are there of doing something? How many possibilities? And of course, for any question like that, the answer does have to be a whole number. Sometimes it's a really big whole number, but it's always some kind of whole number of possibilities. Now, put that together with questions about probability. The probability of something happening is the number of ways that thing could happen divided by the total number of possible outcomes. And sometimes the counting techniques or rules that we've talked about here are the ways to find those numbers of possible outcomes. And then when you divide them, your probability answer is not going to be a whole number. It's going to be a fraction or a decimal between 0 and 1. So that's it for this section about counting rules. They're important for their own sake, and they're also important for their use in calculating probabilities. So there's another section after this one that gets into calculating probabilities with the help of these counting rules and things like combinations or permutations.